Hi everybody. So today in 120 Lab, this is week 2 of our falling mass rotating pulley experiment. We're going to take a closer look at the apparatus and the measurement circuit. So I'll show you what I've got set up here, sort of improvising in my living room, and we'll go through what the circuit is doing, and we'll test out the computer interface and also try to take some data. So I know this is probably a little hard to see since you're sort of looking at this obliquely and I don't have the greatest background here, but I'm going to try to show you how I've set up the physical apparatus. I'm going to see if I can zoom in a little bit here. And yeah. So right here. Oh, where am I? Here I am. Yes. So here we have our pulley, right? And as you can see, we've got this 3-hole pulley. I've set up over here our LED light that'll shine into our phototransistor. Let me see if I can zoom out just a little bit. That's a little bit better, right? And you can see that the light is going to shine through the hole. So I'm going to turn on the proto board here. So you can, I think, see a little bit of light coming through and maybe illuminating my phototransistor. And I have the whole thing set up on this pendulum stand. So let's see, I have a sort of a crossbar mounted here with a clamp, and then I've got the pulley, and then on another clamp that's jutting out, and then I have, similar to how I mounted the LED and the phototransistor for the pendulum lab, I have those sort of in these forks that are also attached to this crossbar over here, and then I've got my my proto board, which you can't see right now, right off the camera. This is a lot harder trying to do this myself without Jill, who was amazing at doing photography. So you probably can't see my face directly in the shot, but I'm going to try to just point out some things in the measurement circuit. I apologize that this is a little bit more of a rat's nest than I would ideally want it to be. I had to just grab equipment in haste when the campus shut down, and if there were more time, I think I would have tried to taken some time to neaten up the wiring, but here we are. Okay, so most of the beginning stages are pretty familiar to you. We have here, right, so this cable is going to my phototransistor. This BNC that I'm wiggling now is powering the orange LED. Now the emitter of our phototransistor, is connected to our resistor, just like that's our 22K, just like we have done all along. Right, here's our Schmidt trigger inverter, same as before. So the thing that's new now is, right, we've got our divide by 2 circuit here. This is our LS74 flip-flop. This orange jumper here that I'm pointing to is connecting the output Q star with data. So that's giving us the flip-flop biting its tail circuit topology. And then the output, which is this green wire, is going to this 74LS08 AND gate. Now a couple of things here. So down over here, this is where I'll eventually connect my reference clock. So this blue wire is going to my AND. The output of my divide by 2 and my reference clock are being ANDed together. But there's one other important difference here, which is that so at the same location I've got this signal, this output from my flip-flop, I also have this green jumper, which is going to my computer interface. This is the signal that's labeled in the manual as data ready to a computer, and I'm not sure what you can see here. I don't think you probably can't read the labels. There's a row of labels along the bottom of this National Instruments interface device. And I've got that green wire connected to pin 1.7, just like we're supposed to. So the rest of this, in some sense, is not so radically different. So we've got just a couple of things. So I'm monitoring the output of my Schmidt trigger here via this long green wire on LED indicator 1. My LED is blocked right now, so in fact that's high. So I'm going to rotate the pulley wheel, and I think I've shown you that can now go low. We also have the output of the flip-flop, so that's also connected here at this at the AND gate, and I've run this orange jumper, and we're monitoring that on LED indicator 2. One other thing, I've got clear star of my flip-flop, which is pin, let's see, that is pin 1 via this brown wire, and that's connected here to push button 1. So if I get this thing to flop, if I press my push button, I've now set the LED indicator for my flip-flop output low. Okay, so that's sort of the beginning stages of this circuit. The next thing, the next parts, right? We have our cascaded, our 3 cascaded counters, just like before, and so here's this sort of light purple wire is our first. So this is this is counting the least significant bit, and this one is counting the most significant bit. The main difference now is that we've connected all of the counter outputs, A, B, C, D, for each of the counters to this National Instruments controller, and the wiring is as described in the lab manual. So I did have to. What else did I have to do? I did have to tie ground of this device to the ground of the entire circuit, so I don't end up with a ground loop. But this is all digital, so probably that isn't super important. But I do have that tied to ground, and then I do have one of the outputs. So P 2.0, this white wire, is tied to the clear of all 3 of the counters. So I've got that running over to here, and then I just ran these white jumpers to pin, let's see, that looks like pin 12 of each one of my 3 counters, so that the computer can in fact clear my counters. Okay, so let's watch what happens. Let's see if the circuit works as expected. So I'm going to clear this. Okay, so you probably can't see this super well, but I'm going to try to. My hand is rotating the pulley wheel here. Let me see if I can. This is not going to work. This is not going to. Yeah. Okay. I'm not going to. Okay. So the pulley is off the camera, and I don't think I can get the circuit and the pulley in sort of one shot. But hopefully, it seems believable that right now there's light shining through one of the pulley holes, and that's why our photo gate, the Schmidt trigger, is low, as you can see at pin 1. My flip-flop is cleared. So let's see what happens when I start to rotate the pulley, and then we start to block some light. And I'm going to reach over here. So I'm now turning my pulley Aha, so I just turned the pulley a little bit. Now light is blocked. So indeed, right, as we expect, the photo gate goes high when light is blocked. Because we're on this first rising edge, our flip-flop has also gone high. Okay, so I'm going to keep rotating the pulley slowly, and so now I've reached I've gone about a third of the way, and we're shining through the next hole. My photo gate now is low, but my flip-flop is still high, because remember, in a divide by 2, it's a toggle circuit where the output only responds to rising edges. So nothing happens yet. So let me turn this a little bit further. And now, right, we are blocking light again, so we have a rising edge, and then, as should be the case for a divide by 2 circuit, my flip-flop has dropped low. Let's just keep on doing this. So turn it a little bit more. Right, now my photo gate has gone back low, and I'm not sure why that just went high. Let's just... okay, let's just clear that and try that again. I might have jostled something. Okay, so we are... Okay, so we're low. Okay, so we're blocking, right, our flip-flops, our photo gate's high, our flip-flops high. Photo gate low, flip-flop still high. Photo gate high, flip-flop low. Photo gate low and flip-flop low, so the next thing that should happen is both should go high if I keep rotating the wheel. Yep, and that's the case. Okay, and now more rotation. Photo gate low, flip-flop still high. Photo gate high, flip-flop low. Both low, and then hopefully we rotate this a little bit more and they're both high again. So it looks like the divide by 2 part of this is working, and let's just check the push button. I think we already did, but if I press the button now, we indeed have the flip-flop output going low, so we're correctly asserting clear star. Oh, and by the way, because it's an active low input, I've got this normally open. Hooked up to normally open, so that when I press the button, I force the signal on this brown wire to go low. Alright, so at this point what we're going to need to do is probably to hook up our function generator for our reference clock. We'll also want to hook in this computer interface and start to see what that does.